All right, this video just goes over a couple of similarity applications, not unlike some of the ones we'll do in class when we meet on Tuesday. First example is actually similar to something we did very, very early on when we were still in live school. Just a quick proportion application. So we have a 42.9 foot tall flagpole that, casts a 253.1 foot long shadow. Then how long is the shadow that a 6.2 foot tall woman casts? Okay, so when we're setting up the proportion, or for any of these word problems, if we don't actually have a triangle in front of us, we could draw it as a triangle if we want, right? So we can draw our flagpole. It's 42.9 feet, right? And our shadow here is 253.1 feet. Right? So we can draw that, and just to indicate that there's a flag there, right? And then we have a woman, right, who is 6.2 feet tall. And then we don't know, this is what we're trying to find out. We don't know how long her shadow is. So, right, we can draw the two similar triangles if we would like to. We can also just think of this as, we're comparing the actual height of something to the shadow length of something as a proportion. So it's up to you how you like to look at these problems when there is no diagram there. All right, so we have the flagpole. It's 42.9 feet, and its shadow is 253.1 feet. And we're looking for how long is the shadow of the woman that is 6.2 feet high. So again, you're seeing that we're looking at the actual height up on the top of our proportion. We're looking at the shadow length at the bottom. This side of the proportion is looking just at the flagpole. This side of the proportion is just looking at the woman. We also could compare, right, the actual height of the flag to the actual height of the woman, and the shadow, the flag's shadow, to the shadow of the woman. Both of these proportions have the same cross products, right? You'll notice in both cases we're multiplying 6.2 by 253.1, and then we're going to divide by 42.9. So in either case, we're going to get the same answer. And when we do that calculation, we're going to get that x is approximately equal to 36.6 feet. So her shadow is roughly 6 times as long as her height, right? Same thing here. If we think about, approximately 40 feet and we multiply that by 6, right? 240. So we're looking at the shadow length being about 6 times as long as the height of the actual object. All right, the next example also deals with the shadow, something casting a shadow. It's a little bit of a different example, and we can actually see our triangles here too as well. So we have a 12 centimeter rod that's held between a flashlight and a wall, right? So this is 12 centimeters. And we want to know what is the length of the shadow on the wall if the rod is 45 centimeters from the wall and 15 centimeters from the light. So that's telling us that this here is 15 and this here is 45. So I'm actually going to pull one of these triangles out. It happens to be a right triangle, but I'm going to pull, oops, I didn't do a very good job of drawing that, but I'm going to pull that triangle out, right? And I'm going to draw this here because now this figure looks very familiar, right? So this rod is really parallel to this shadow or this wall, right? And we know we're given that this is 15, right? This is my flashlight here, right here, right? So we know that this is given, this is 15, and that this is 45. And this was the rod, but this is only half of the rod, right? See how I pulled this part, this triangle out, and I drew it here. So this is only half of the rod. So instead of the full 12 centimeters, which would be down here, right? The rest of it would be down here. I'm going to call this 6. And now take a look at this. This looks just like those problems we were doing last week, right? Where we have a similar triangle inside of another similar triangle. So if you want, I could even redraw those two similar triangles. I could have that 15 and that 6, and then I have this whole length here, right? And this whole length here is 15 plus 45, so that's 60. And I'm going to call this x. In this case, this, right, this is only half of my shadow, right? It's half the length of my shadow. So if I find x and then double it, then I have the whole length of my shadow, right? So I can set this up 15 over 60 equals 6 over x. So x is 24 centimeters, but keeping in mind that that's only half of my shadow, I need to multiply that by 2, right? So 24 times 2 is going to give me 48 centimeters for my whole shadow. And then finally we have, again, you're going to see this diagram here, very similar to the problem that we just did. Right? So we have a tourist on an observation deck of a building, right? She's up here, facing another building, 320 feet high. Her view is 400 feet above the street level. And from here, she can just see her car, right? So her line of sight, she is just able to see her car. So she can see just over this building here, and she can see her car out over here. How many blocks apart are the building and the observation deck? So this is what we're looking for here, right? And we know it tells us that her car is 5 blocks from this shorter building here, right? So you can kind of see these triangles in here, right? We have, again, pretty much the same diagram we had in the last problem, right? So we have 320, we have 400, we have 5, and then we have some unknown here. Now this unknown is only a piece of the bigger triangle, right? So we're going to take a look at it like this here. So this is the big one. So 400 times, not 400 times, x plus 5 is going to be some number there, right? And this is 320 and 5. All right, so I could either think of this as x plus 5 if I want, or I could just find this entire length. I could call the entire length, we can call it a if we want to, and then I could subtract the 5 from it to figure out what this piece is. So it's up to you, whatever you're more comfortable with, right? So this is, this proportion would look like this: 400 over 320 equals a over 5, if I just wanted to use, a variable for this entire length here. And then if I cross multiply and divide, I get that a is it's exactly 6.25 blocks. Now keeping in mind, again, that I decided that this whole thing was going to be a, right? So this entire thing from here to here is 6.25 blocks, which means that the distance between these two buildings is going to be 6.25 minus 5, which is 1.25 blocks here. And again, just to clarify, if I had decided instead of using a to use the x plus 5, then my variable just represents something different. My variable actually represents this little piece here that I was looking for. So I could do it that way if I'd like to, if I'm comfortable doing it that way, right? And I get 2,000 equals 320x plus 1,600, right? So 400 equals 320x, and then when I divide 400 by 320, I get that 1.25. So either method here is completely fine. It just depends on how you like to look at this big side of this triangle. So we'll look at some more examples very similar to these in class the next time we meet.